to run through. The most common mistake I saw on this problem when I was grading it is this function right here. All right, so these are all functions of x, and we're asked to take the derivative with respect to x. So I don't see any x term right here. So this is a constant. It's just a number, right? So its derivative is 0. I saw some people writing like 6 pi. Sure, if we were taking the derivative with respect to pi, but pi is just a number. Pi and e are just constants. So if there's no x attached to your expression, then its derivative is going to be 0. All right, the rest of these were pretty chill, right? Derivative of x is 1, 10x is 10, e to the x is just e to the x. Now for e to the x, when we take this derivative, we can bring the 4 out in front because there's no x there. So we get 4 times derivative of e to the x. So we just get back 4e to the x. All right, we got to be careful with this next one because now we have 3 in the exponent. So we're going to get 7e to the 3x times the derivative of that exponent, which is 3. So that gives us 21e to the 3x. All right, 6 sine x, again, because we have a constant, we can rewrite this as 6 times the derivative of sine, which we know is cosine, so we just get 6 cosine of x. This next one, so we have a constant, but it's with the x. It's with the cosine, so we can't pull it out in front. Instead, this is going to be a chain rule. So we do derivative of cosine 8x, which is negative sine 8x. But because our x is multiplied by 8, we get negative 8 sine 8x. All right, this next one we have ln. So a common mistake I saw was people just saying that the derivative of this guy was just this. You're close. You're close. So the derivative of ln of x is 1 over x because it's the derivative of x divided by the original function. So anytime we take the derivative of natural log of a function, its derivative will be derivative of that inside divided by the original inside. So we should get 2x over x squared plus 1. Okay? No ln shows up in the derivative. And then this last one, so again we have this 7 in front, so we can pull that out and deal with her later. And then derivative of secant is secant tangent. So that's just kind of one of the ones you just have to know. If you forgot what the derivative of secant was or tangent was, and you're like, oh my gosh, I'm never going to remember it, let me show you how you can derive it in case you forget. So secant is just 1 over cosine, right? So if I wanted to take the derivative of secant, I could just take the derivative of 1 over cosine and use a quotient rule, where this is f and this is g. So then our f prime is 0, our g prime is negative sine. So if we do the quotient rule, we get f prime g, so that's just 0, minus g prime f, so we'll have negative sine of x. Well, minus negative, so it's really a positive, all over g squared, so cosine x squared, which is sine of x over cosine squared, which is also equal to 1 over cosine times sine over cosine. Lo and behold, this is also secant tangent. So if you're in a pinch and you don't remember how to do secant, its derivative, you can use quotient rule. Same thing with tangent, because tangent is sine over cosine, and we can do the same thing for the quotient rule if we were to forget how to take its derivative.